What if I told you there are asteroids lurking near Venus that we can't see, and one day, they might head straight toward Earth? We call them invisible asteroids, and they're currently slipping through our planetary defenses. In this video, we'll dive into how astronomers discovered this hidden threat, what makes them so hard to detect, and whether Earth is really in danger. Stay tuned. First, a bit of orbital mechanics. A co-orbital is an object that shares a similar orbital period around the Sun as a planet, in this case, Venus. That means these asteroids don't orbit Venus itself, but they dance around the Sun in lockstep, sometimes leading, sometimes trailing, sometimes crossing paths. They are sometimes called Venus co-orbital asteroids. Right now, astronomers have identified about 20 such Venus co-orbitals, but here's the catch, almost all of them have high eccentricity. I'm are elongated, which pushes them away from the Sun at times, so they're more visible when farther from the glare. The study suggests that there may be a larger hidden population of similar asteroids, but with lower eccentricity, which keep them far closer to the Sun's glare, making them nearly invisible to our telescopes. Why do we call them invisible? Because their orbits place them very close to the direction of the Sun from our viewpoint. That means when telescopes try to look for them, the Sun's glare overwhelms the faint reflected light from the asteroid. The simulations from the recent paper indicate that some of these hidden asteroids could have eccentricities below 0.38, meaning more circular orbits, and thus remain persistently close to the Sun in the sky, making detection extremely difficult. Even with a powerful telescope, like the Vera Rubin Observatory, LSST, these objects would only be visible for a brief window, maybe 1-2 weeks, and only if they stray more than 20 degrees from the Sun in the sky. For long stretches, they'd vanish again, hidden behind the Sun's brilliance. So, do these hidden asteroids pose a real threat? According to the study, yes, on long timescales. The researchers ran simulations over multiple co-orbital cycles, thousands of years, to see which objects might drift into Earth's vicinity. They found that objects with low eccentricities and lower inclinations are more likely candidates to eventually intersect Earth's orbit. Some of these hidden asteroids could be as large as 300 meters in diameter. If one of those struck Earth over a populated area, the impact could form a crater 3 to 4.5 kilometers wide and release energy comparable to hundreds of megatons. Devastation on a massive scale. Science alert. So, now, before you panic, the researchers emphasize that none of the currently known co-orbitals are on a collision course with Earth anytime soon. Space. But the hidden population is the worry. These are objects we can't see yet. Over millennia, gravitational interactions, especially from planets including Earth, Venus, etc., could nudge some of them into dangerous orbits. Even smaller asteroids pose detection challenges, and sometimes they slip through unnoticed. For example, on October 1, 2025, an asteroid dubbed 2025 TF passed just Mach 266 miles, 428 kilometers, above Antarctica, closer than many satellites, yet it was only discovered hours later by surveys on Earth. That one was small, estimated at 1 to 3 meters wide, and posed no major threat, but it shows how even nearby space rocks sometimes evade early detection. These near misses highlight just how vulnerable our detection network is, especially for faint and fast objects. So, what's the solution? How can we peer into this blind spot near the Sun? One promising proposal is space-based telescopes that can observe regions very close to the Sun, avoiding Earth's atmospheric glare constraints. Missions like NASA's NEO Surveyor, Target Launch, DAT 2027, are designed to find near-Earth objects, including those currently hidden. Another idea, place observatories in Venus orbit or other inner solar system vantage points, giving a different geometry from which to see these co-orbitals more clearly. The paper argues that planetary defense must not only focus on what we can see, but also what we can't yet see. Over time, improved surveys, all-sky monitoring, better algorithms, and new mission designs may help us track down these stealth asteroids before they drift into dangerous paths. So, where does that leave us? Should we be terrified tonight? No. There's no imminent threat from known objects. But the study is a reminder. Our current asteroid surveys have blind zones. Hidden space rocks may lurk undetected. Over centuries or millennia, some may wander into Earth's orbit due to gravitational shifts. If one is large and hits in a populated region, it could cause catastrophic damage. For now, we need to push for better detection, not just of what's visible, but of what's hidden. If you're excited about space, follow the upcoming missions, track news about asteroid detection, and maybe one day we'll have the technology to see every rock in our solar neighborhood, visible or not. If you like this deep dive into invisible asteroids, give it a thumbs up and subscribe for more astronomy mysteries. Let me know in the comments what space topic I should cover next. Black holes, exoplanets, rogue planets, you name it. Thanks for watching, and keep looking up.